Hey guys, sorry this video is coming out a little late. This is me going over the review over the 115 worksheet that you guys should have gotten today. Extra credit and all that. We're just gonna get started because I'm going crazy trying to get on here and I want to stop doing takes. Let's get going. All right, so for this first problem, we can see we're looking for what binomial is a factor of 9x cubed minus 36x minus 6x squared plus 24. So the first part of this is saying, okay, we see what binomial. A binomial just means two terms. It is a two-term answer that usually has x and some number combined together. So we can see for our answer choices, we have four binomials to choose from. In order to find out which one is correct, we need to factor out this problem completely. Now, in order to factor this, we need to first count the amount of terms. We got 1, 2, 3, 4, 4 terms. If it's 4 terms, that is grouping. This is going to be a grouping problem. Sorry for the bad handwriting. It's a grouping problem. The way you do this, remember, step 1 is you want to split the problem. Now split into two groups. Grouping, groups, get it? Two groups. Make sure the sign of the third term, by the way, belongs with the number that comes before it. Now, first, let's look at the left side. Focus on one side at a time. When you want to ask, what can we take out? I always say, do the number first, then worry about the variable. Let's do our numbers first. We have 9 and we have negative 36. What number can be divided by both of them? Well, if you find your GCF, you would find here that 36 can be divided by 9. And 9 is the largest GCF, or like the largest factor of 9, so we can only divide by 9 on each of these. When we do that, we're going to take that, put on the outside of a new parentheses, and then rewrite what's inside. 9 divided by 9 is 1, which kind of cancels out. So we're going to drop x cubed. And negative 36 divided by 9 is negative 4. We drop our x. Just next to it because that didn't go anywhere. Now we're going to do our variables. Now we're divided by variables. Remember, the most important part is picking the variable that has the lowest exponent. And you remember, x technically has a tiny little exponent of 1. It's invisible, but it's there. Remember that. So, what we want to do now then is we want to divide by x, or x to the first power. That's way too thick. X to the first power. So, what that means is we're going to divide each side here by x. Now, we're going to take that x, put it on the outside. So our outside part here is going to be 9x, and the inside part is going to be x cubed divided by x. Well, that's x squared minus 4, and that's it. Because x divided by x is 1, which cancels out. So we have our first part here, 9x times x squared minus 4. Our part of grouping is we need to make sure that each of these parts have this inside part over here. Like this x squared minus 4 needs to be the same between both of them. So make sure that we're looking for that in our second part here. So let's get started. We have negative 6x squared plus 24. Remember, if the first term is negative, you need to divide by a negative. So 6 and 24 have 6 in common. This is our greatest common factor. We're not just dividing by 6 here, we're dividing by negative 6 because the first term is negative. So negative 6 divided by 6 cancels out. Let's be sure to take that on the outside, by the way, right here. Now the inside, well, negative 6 divided by negative 6 cancels out. We can drop the x squared, and then 24 divided by negative 6 is negative 4. Hey, look at that, we got it again. So that means you know you did it right. If you got the second part twice, you should have gotten to here. Now, we're continuing a little further. We have 9x times x squared minus 4, and we have negative 6 times x squared minus 4. They are the same thing. You can combine them. So I'm also going to write over here real quick. Step 2, by the way, is factoring. That's what we just did. Divide by everything. Step 3 is combine. Let's do that. Remember, in our first parentheses, we put what's on the outside. So we have 9x here, and we have negative 6. So I'm going to highlight those in pink. 9x and -6. So we're going to put both of those into our first parentheses. 9x minus 6. In our second parentheses, we are going to be putting x squared minus 4. So, now, what we're doing here is we're saying, okay, so we have 9x minus 6, and we have x squared minus 4. Gotta look at our problem so far. We have A, B, C, D. A is already wrong because it's going to be x squared minus 4 in the first place, so that doesn't make sense. X minus 6 doesn't make sense because even if we factor out a 3 in the first parentheses, it's not going to mean that. X minus 4 doesn't make sense because it's x squared, but let's look at x plus 2 because that's also not in there. So I can tell what the answer is. Remember, this is following the pattern of a squared minus b squared. That is a difference of squares. So this can actually simplify to x plus 2, x minus 2. Mix it up. X plus 2 is one of our answers. X minus 2 is still part of it, of course, but this is what we're looking for. Our answer choice here is D. X plus 2. All right, so now we're going to go on to our, hey, when do we use each method? So when you use combining like terms, what this means is when we have two parentheses that are being added or subtracted to each other. This is when we use combining like terms. There are two sets of polynomials in each of these parentheses, and we're adding or subtracting them together. That is what's going on in this one. When do we combine like terms? Adding or subtracting. When do we use box method? Well, when we are multiplying. Remember, when two parentheses are touching like this is multiplication. Let me just highlight that real quick. That is multiplication. That's when we use box method. All right, how to identify if it's a factoring problem? Well, how do we know it's a factoring problem? Either A, it'll ask if it's a factoring problem, like it'll say, hey, can you factor this? Or B, you'll probably see like some kind of terms like this, with binomials factor. Factor is the big keyword, making this problem up here. Or you're going to see like sets of parentheses everywhere. Essentially, if you see parentheses everywhere, that's how you know it's some kind of factoring problem. Also, another keyword as well, GCF. If you see a common term between the polynomials, it's probably a factoring problem. So what's always the first step to factoring? Well, I just kind of said it. GCF. You always want to find the GCF first before we do X method, before we do difference of squares, before we do anything else. Always factor out the common terms. And when the first term is negative, when factoring, the GCF must be negative. Always remember that. Like let's say we had negative 4x minus 10. You aren't factoring by 2, even though 4 and 10 have 2 in common. You are factoring by negative 2. You have to make sure that negative sign is there. All right. Let's go on to number 1. 5x squared plus 3y minus 2 plus negative 3x squared plus 4y squared plus 5. Now, don't overcomplicate this. Look at what is in the middle. Plus. So what does that mean? Step 1. Combine like terms. Step 2. Done. Adding is the easiest of these problems. Do not overcomplicate this. Combine like terms. So what does that mean? When you are combining like terms, just add together what's in common. 5x squared can only be combined with other x squareds. And would you look at that on this side? Negative 3x squared. Let's combine them. 5x squared minus 3x squared? Well, that's 2x squared. Let's go to our next one. Positive 3y. Can we combine it with anything on the other side? You may think, oh hey, y squared. That is incorrect. Do not do that. You cannot combine 3y and positive 4y squared. They need to have the same letter and the same exponent. So yes, while they have the same letter, the y, sorry, let's just get that real quick. They do not have the same variable. Keep that in mind. All right. That's not what I want to do. All right. So let's just kind of drop things down then. Now, when you're ordering these, always make sure highest exponent goes first. So we're first putting this positive 4y squared, and then we're going to do the positive 3y. Just drop them because you can't combine them. And finally, last but not least, -2 and +5 are both constants, so we can combine them. They don't have letters, so we can combine them. -2 plus 5, well, that's +3. There we go. Ta-da! All right, let's move on to number 2 now. So you may notice this one's a little different. How so? Well, let's look. That's a minus sign, not a plus sign. So what does that mean? Step 1 is a little different this time. Step 1, distribute the negative. We need to distribute the negative. Then you combine like terms or CLTs. So we're going to take this negative sign here. We're going to distribute it to all of these. What that means in practice is just flip the signs. So we're going to first drop everything in this first area. Nothing changes with the first parentheses. In the second one that's been edited, we're going to change it to a plus after we distribute. What's the opposite of 3x squared? Well, -3x squared. What's the opposite of -2y squared? +2y squared. What's the opposite of -1? +1. Now you combine like terms. So let's do that. Our first term here is 8x squared. Can we combine that? Yes, we can. -3x squared. So 8 minus 3 is 5, and then x squared. That doesn't change. This isn't multiplication or division. Let's go to our next one now. 12y squared and 2y squared. Well, those are both y squared terms, so we can combine them. Well, that's 14y squared. And finally, we have our two constants here. We can combine them because they have no letter. So 3 and 1. Well, that's pretty easy math. 4. There's our final answer. Hooray. All right, let's go into our next problem. 6x plus 6, and then 2x cubed plus 3x plus 4. All right, so first thing you notice, what operation is happening? Well, let's look at here. Oh, hey, look at that. That's multiplication. Because how do you know? They're touching. If you don't see anything between them, that's multiplication. They're bordering like that. And the same way, it's like 2x is 2 times x. Now, we are going to first box. This is box method. Pretty straightforward. We're going to make our box just based on how many terms are in each. So count your terms. In the first one, we got 1 term, 2 terms. In our second one, we got 1 term, 2 terms, 3 terms. So we are making a 2x3 box. So I'm going to design it down here real quick. Let's just do that because I'm a great artist. Made it too thick again. Whatever. Don't got time. So we got a 2x3 box. It does not matter if you draw it vertically or horizontally. All that matters is you make it. All right, so on the 2 side, we have these two terms, x and +6. On the top side, we got 2x cubed, 3x, and 4. Now remember, in each of these boxes, you are multiplying. Then step 3, CLT. So let's do that. In this top left box, again, we're multiplying. This is the same as saying x times 2x cubed. So what that makes together is 2x to the 4th power. Side note, remember, when you are multiplying exponents, x to the 3rd power times x is x to the 4th power, because exponent math is addition when you are multiplying. You're adding them together. So for another example, let's say we had x squared times x squared. Well, that's x to the 4th power again, because 2 plus 2 is 4. One more example just for the road. X cubed times x squared. Well, that would be x to the 5th power, because you are adding these two exponents. 3 and 2 make 5. All right, with all that out of the way. So I'm going to erase that. Got space later. let's just multiply the rest of these boxes real quick. 3x times x, that's 3x squared. 4 times x, that's 4x. 2x cubed times 6 is 12x cubed. 3x times 6 is 18x. And 4 times 6 is 24. Now we're going to do our last part here, CLTs. We are going to add now. So, combine like terms. Combine what has the same exponent and letter. Let's just kind of start from the top left. Always start from the highest degree, or exponent. So, 2x to the fourth power is our highest exponent, so we're going to drop that because we can't combine it with anything. Cross it out. Let's go to the next one. X cubed is the next highest here. So, can we combine it with anything? Check them real quick. No. So, drop it. Cancel it out. Let's go to the next one. 3x squared. We can't combine that with anything. Drop it. Pretty straightforward process. All right, now this is why you have to check every one, not just drop them. 4x and 18 can combine. These can combine. So we got to combine them into 22x. And finally, we have 24. Yeah, and that's our final answer. We can't combine anything else. We're done. All right, we're going to go on to number 4 now. X cubed plus 5x squared minus 3x minus 15. Again, this is 4 terms. Just count them real quick before you go too far. 1, 2, 3, 4. This is 4 terms, and 4 terms means grouping, kind of like that warm-up. So, let's do that. Again, step 1 is grouping, is to split the equation. Step 2 is to factor out both sides. So first, let's look at x cubed plus 5x squared. They don't have a number in common, because 1 and 5 can't be factored. So we need to divide by x to what power? Again, it's always the lowest one, so it's going to be x squared. We're going to take that outside of the parentheses, and then on the inside of the parentheses, well, x squared divided by x squared cancels out. X cubed divided by x squared is x, and 5 just kind of drops here because x squared canceled out. And kind of remember, like last time I was saying, you know, how this is exponent addition. Well, exponent division is subtraction. 3 minus 2 is 1. That's how we're getting the x here. All right, that one's done. Let's go to the next one. We have negative 3x and negative 15. Again, remember, first term is negative. We need to divide by negative. Take that out, negative 3 times, and then if you did this right, this should be the same. These should be the same. So now we can combine them. So x plus 5 and x plus 5, well, that makes x plus 5. You don't change anything there. They share the same part. So now we take what's outside. We're going to put them into another parentheses of x squared minus 3. Now, the important part here is to check for the difference of squares. Say it again. Check for a squared minus b squared. And you can kind of see here, x squared minus 3. Is that difference of squares? No. 3 is not a perfect square, so we are just done here. This is the final answer. But again, you have to keep an eye out for that. All right, number 5. This is 3 terms. Let's count real quick. 1, 2, 3. 3 terms usually means X method. So, but in order to do that first, you still have to remember, first step of all these, GCF, then do X method. So first determine what we can take out of all 3 of these. Well, we can take out an X. We can't take out a number, but we can't take out an X. Because again, like all 3 of these don't have a number. Like you can't factor anything out of 1. So we're going to take X on the outside. And then from here, x cubed divided by x is x squared. Negative 3x squared divided by x is negative 3x. Negative 40x divided by x is just negative 40. Now we're going to do our x method. So we're going to make our big X. Do it like that on here. Top is a times c. Bottom is b. Our a, b, and c values here, by the way, well, a is 1. B is negative 3, and C is negative 40. So A times C here is negative 40, because negative 40 times 1 is negative 40. Our B value is negative 3. So what two factors of negative 40 can add up to negative 3? Well, if you need to make a factor chart for this, go for it. Keep in mind, this is negative 40. One is positive, one's going to be negative. It's going to be subtraction. So 1 and 40, 2 and 20, 4 and 10, 5 and 8, and oh, wait, I think I see it. 5 and 8 subtract to give us 3. So, if we know one's positive, one's negative, it's going to be subtraction of some variety. 8, 5. The important part is deciding which one has a negative sign. If it's negative 3, it's the larger number that has a negative. So, now we're just going to finish this up by rewriting our equation. The x stays on the outside. Do not forget this x. Then we rewrite our quadratic to have our new factors, x minus 8 and x plus 5. Just took these and shoved them in here. That's it. Finally, number 6. All right, we see 4 terms, so I want you to think for a second what that is. If you said grouping out loud, great job. If you didn't, shame on you. Not really. You're here to learn. This is a grouping. So, similar to the other problem, we're just going to get into it. You should know how to group by now. So, first, factor out the first part. X cubed and x squared, 2x, negative 2x squared, share x squared in common. Again, divide by the smaller exponent. Take x squared on the outside, on the inside, x minus 2, because it's x squared divided by x squared, cancel that. All right, and on the other side now, you have negative 25x plus 50. Again, first term is negative. Divide by that negative. That negative is super important, guys. Keep an eye out for it. And on the other one, divide by negative 25. We can take that out of both of them. And then x minus 2. All right, now we're going to rewrite it. Let's get rid of some of these dots down here. All right, in our first one, we're going to put x squared minus 25. Our second one, we're going to put x minus 2. And if you're confused about where that comes from, x minus 2 just kind of goes to the right over here. And then we're going to put x squared minus 25 into both of these. All right, but now, if you remember from my last time, check for a squared minus b squared, aka the difference of squares. Well, is it here? Well, look over yonder. That was a highlighter instead of a marker, but it still works. You need to check for a squared minus b squared, and it turns out we found it. Keep in mind, x squared is a perfect square, because a squared is x squared. When you square root both sides, a equals x. There's no leftover square root, there's no decimal or anything like that. That's why it's a perfect square. B squared, in this case, is 25. Always ask yourself, or just test in a calculator, is this a perfect square? Square root both sides. And if it gives you a number that is not a decimal and does not have a leftover radical, aka square root, that is a perfect square. So A and B are x and 5. Remember, it was a plus b, a minus b. So we're just going to rewrite x squared minus 25 as x plus 5, x minus 5, x minus 2. That x minus 2 did not go anywhere. That still stays there. Don't get rid of it. And yeah, all we did is we just difference the squares. The x squared minus 25. So keep an eye out for it. This is your final answer.